could have just run off that. All right. Good morning. If you're joining us today, we are going to be talking about solving trig equations by factoring. We got a little taste of this in the last lesson, but now we're going to work through more complicated problems. So these notes were sent out at the last minute, and you may not have had a chance to download them. And if you didn't, that's fine. Just get a piece of paper, take a minute, and write down this first equation. We're solving 2 sine squared minus 3 sine plus 1 equals 0. And we're trying to find the values of x that make this true. Now, again, when you're looking at this, please don't be intimidated by the trig that's in the problem. In other words, if you saw 2x squared minus 3x plus 1 equals 0, you would be able to solve that. You'd be looking, of course, for factors of 2 that add to give you 3. So you would factor, and you would have, my signs are the same, they're both negative, so you'd have negative 2 and negative 1. So you would end up with x minus 1 and 2x minus 1. No problem. Yeah? Okay, sorry about that. So you're going to use that exact same mathematical usage when you're dealing with the trig. It's no different. So again, I've got 2 sine squared minus 3 sine plus 1. So again, I'm looking for factors of 2 that add to give me 3. So everything's going to be the same. I'm going to come back over here, and I've got negative 2, negative 1. The only difference is this time, instead of x minus 1, you're going to have sine x minus 1. And here, instead of 2x minus 1, you're going to have, of course, 2 sine x minus 1 equals 0. So there you've exposed the 2 factors. The difference is we're going to have to find out where this is true. So you're talking about a little bit of sine inverse here. So my first factor, sine x minus 1 equals 0. Yes. So I'm going to take sine x minus 1 equals 0, sine x equal 1. So now you're into your inverse. What angle has a sine value of 1? What angle has a sine value of 1? That's what you're really asking here. I know it's been forever since we've done our unit circle, but if you think about that, sine, of course, starts at 0, goes to 1, back to 0, and negative 1. There is only one value of x that would make this true, and that value is pi over 2. Okay. Now, let's look at our other factor. 2 sine x minus 1 equals 0. So we're looking for a value of x that gives you what angle has the sine 1/2. Okay, so if we think about that, sine is positive in quadrants 1 and quadrant 2. So my answer is got to be in one of those 2 quadrants. And sine is coming off of 0 at 0. The first step it takes is 1/2. So pi over 6 and 5 pi 6. So when I'm asking, find the values of x that satisfies this equation between 0 and 2 pi, 2 sine squared minus 3 sine x plus 1, I have 3 values that make this true. X is pi over 2, x is pi over 6, and x is 5 pi 6. So again, I don't mean to be rude about this, but when we started factoring at the first of the year, and I said, you're going to be factoring without numbers, here we are. All right, let's look at the next problem. Take a minute to write it down if you didn't have a chance to download the papers. And by the way, all the next lessons, I'll be sending those pages out today. And I'm not sure if we're going to be going live again, but all the other videos will be on Billy's Live, and you can download them anytime and watch them when you have time. All right, so we have 2 sine x cosine x equals root 2 cosine x. So as with any other factoring problem, you want to get all your terms to one side. So what I'm going to do is subtract the root 2 cosine x. So I have 2 sine x cosine x minus root 2 cosine x equals 0. All right. Now, what's our common, well, first rule of factoring, of course, don't talk about it. What's our common factor here? The cosine x. So I'm going to take that out, and that leaves me with 2 sine x minus root 2 equals 0. So there are my 2 factors. I have cosine x, and I have 2 sine x minus root 2. So I'm going to set the first factor to 0. Cosine x equals 0. So I'm asking what angle has the cosine of 0? And of course, that's going to be pi over 2 and 3 pi 2. Now, let's look at the other one. Now I've got 2 sine x minus root 2 equals 0. 2 sine x equal root 2. I'm just adding the root 2 to both sides. I'm going to divide by 2. And the sine of some angle is square root of 2 over 2. Well, of course, that's one of the angles we know. And again, sine is positive in quadrant 1 and quadrant 2. So the answer is pi over 4 and 3 pi 4. So I have 4 values of x that make this true. Pi over 2, 3 pi 2, pi over 4, 3 pi 4. Okay, let's head to the back. Again, if you haven't had a chance, here's the problem. I've got cosine squared plus 6 cosine plus 5 equals 0. So you may want to look at this as x squared plus 6x plus 5 equals 0. All right? Again, we're looking for factors of 5 that add to give us 6. Our signs are the same. They're both positive. So I'm going to have plus 5 and plus 1. There's no leading coefficient. I won't be dividing. Now, instead of x, my variable is cosine x. So if I multiply this back together, I get cosine squared. 1 cosine plus 5 cosine is 6 cosine, and 5 times 1, of course, is 5. Okay, let's take our first term. We're saying what angle has the cosine? -5. Well, what angle does have the cosine -5? Remember, cosine starts at 1, it goes to 0, -1, and 0. So your range of cosine is between -1 and 1. There will never be a time that the cosine of any angle is -5. So there's no solution on that side. Now let's go to the other side. Cosine x plus 1 equals 0. The cosine of some angle is -1. Well, there's only one place that happens, and that is at pi. So in this equation, we only have one value of x that will make this true, and that value is pi. All right. Take a minute to write it down. Cotangent squared minus cotangent squared, cosine squared, is 0. Okay. First rule of factoring. What is common to both these terms? Well, of course, cotangent squared. So let's take that out. Cotangent squared x, and I'm left with 1 minus cosine squared x. Okay. So there are my two factors. The cotangent of some angle squared is 0, and 1 minus the cosine of some angle squared is 0. So let's find out what these angle measures are. We'll start with cotangent x equals 0. Of course, you're going to square root both sides. So the cotangent of some angle is 0. Well, cotangent is cosine over sine. And I know that's not going to happen at pi over 6 because I got root 3 over 2 and 1/2. And it's not going to happen at pi over 4 because it's root 2 over 2, root 2 over 2. And it's not going to happen at pi over 3 because I've got root 3 over 2 and 1/2. The only place this can happen is at the quadrangles. So it's either at 0, pi over 2, pi, or 3 pi 2. So let's think this through. If it's at 0, then I have 1 divided by 0. Clearly, you can't divide by 0, so that will not work. If it's at pi over 2, then I have 0. I want to write this down. Then I have 0 over 1. And that does work. So I've got two answers for where cotangent squared x equals 0. I have x value of pi over 2 and 3 pi 2. Okay, let's go to the other side now. And now we're saying 1 minus cosine squared x equals 0. So now we're looking for cosine squared x is 1. Okay, we're going to take the square root of both sides. What angle has the cosine of 1? Well, as we just said, that happens at 0 and it happens at 2 pi. However, this other side of the equation says, no, 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 you can't use 0 as an answer because you blow up our denominator there. So none of our answers here, I beg your pardon, this should be plus or minus 1. Square root of 25 is 5 and also negative 5. So, duh, I forgot a simple thing. I would also include pi in that answer. But be that as it may, it still won't work because of this side of the equation. So there are only two answers that are going to make this true. Okay, let's work some practice problems. Again, if you didn't have a chance to download it, here we go. 2 cosine squared plus cosine equal 0. Okay. First rule of factoring. So here we go. We're going to take out a cosine x, and I've got 2 cosine x plus 1 equals 0. I'm going to set cosine x equal to 0, and that's true at pi over 2 and 3 pi 2. And then I've got cosine x equal negative 1/2. Cosine is negative in quadrants 2 and quadrants 3, and we're one step off of 0, so we're 2 pi 3, excuse me, right here, and 4 pi 3. So I have 4 answers there that make that true. All right, let's look at problem 3. 2 sine squared minus sine minus 1. So now 2x squared minus x minus 1. You would do that by factoring. Factors of 2 that subtract to give me 1. And again, instead of x, it's going to be, I'm looking for where the sine x minus 1 and 2 sine x plus 1 equals 0. So I've got 2 sine squared plus sine minus 2 gives me negative 1. Negative minus 1 is 0. Okay, so here we go. What angle has a sine of 1? Well, there's only one angle that it makes that true, and of course that's pi over 2. What angle has a sine of negative 1/2? Seven pi 6 and 11 pi 6. So those are our choices there. All right, let's look at 5. 2 cosine squared x equal cosine x. Be careful here, because if you divide by cosine, you're going to lose one of your terms. And it's very tempting to want to do that and just say 2 cosine is 1, which that does give you half of it. But what you really want to do, again, if you had 2x squared minus x, you'd move the x to the left. So we're going to do the same thing. So we've got 2 cosine squared x minus cosine x equal 0, which looks very similar to problem number 1. GCF, cosine x, so I'm looking for where cosine is 0 and where cosine is 1/2. Okay, cosine is 0 at pi over 2 and 3 pi 2 and 1/2 at pi over 3 and 5 pi 3. Okay, let me give you the answers to problem 2 and 4. On problem 2, your answer is pi over 2 and 3 pi 2. Problem 4, you only have one choice, and it's going to be pi. And let's work problem 6 together. Cosine squared minus 4 over cosine minus 2 is 1. So what I'm going to do, I'm going to multiply both sides by this denominator to get rid of it. So I've got cosine squared x minus 4 is cosine x minus 2. Now I want to get all my like terms together. So I've got cosine squared x minus cosine x, because I'm subtracting it and moving to the left, minus 2 is 0. Because you're adding 2 to both sides, negative 4 plus 2. Now, factors of 2 that subtract to give me 1. And instead of x, I have cosine. That gives me cosine squared minus cosine minus 2. All right, so I'm looking for the value of x that gives cosine, what angle has a cosine of 2? And again, negative 1 to 1, no angle has a cosine of 2. And then cosine is negative 1. That only happens in one place, and of course that is pi. A little bit different on that problem. I just want to make sure we're not completely lost dealing with that denominator. All right, let's look at problem 5. 2 sine squared minus 5 plus 3. Again, if it was 2x squared minus 5x plus 3, you'd be looking for factors of 6 that add to give you 5, right? We agree? So you'd have minus 2 and minus 3. Of course, you artificially multiply by 2, so now you can divide. So now I've got sine x minus 1 and 2 sine x minus 3. Okay? equals 0. So we're looking for a value. What angle has a sine 1? And there's only one angle that does that, and that would be pi over 2. And then we're looking for what angle has a sine value of 3/2. I don't know if you can see behind me, but again, think about your output values of sine. Your choices are between -1 and 1. 3/2 is 1.5. There is no angle of sine that's going to have a value of 1.5. Okay, let's look at problem 9. 2 secant squared x minus 2 secant equals 4. Okay. First thing we're going to do, get all our like terms together. So we've got 2 secant squared x minus 2 secant x minus 4 is 0. I'm going to factor out a 2. Secant squared x minus secant x minus 2 is 0. Factors of 2 that subtract to give me 1. So I have secant x minus 2 and secant plus 1 equals 0. So I'm looking for secant value of 2 and a secant value of -1. Okay, remind yourself, what is secant? Well, secant is 1 over cosine. So in order to have a secant value of 2, 1 divided by what is 2? Well, let's think about your major angles. 1 divided by 1, 1 divided by square root of 3 over 2, 1 divided by square root of 2 over 2, 1 divided by 1/2. There you go. That's what we're looking for. So cosine has to be positive, and it has to be 1/2, and that's going to happen at, in quadrants 1 and quadrants 4. So I've got pi over 3 and 5 pi 3. Now, secant has to equal -1, which means cosine has to equal -1. And cosine equals -1 at pi. Do we agree? Yes? No? Maybe? That's it? All right. Let's look at 11. I think I got one more problem in this pen, and then I'm probably done. 4 tan squared minus x minus 1 equal tan squared x. So I'm going to subtract a tan square x from both sides. So I have 3 tan squared x minus 1 equals 0. All right. So now I've got 3 tan squared x equal 1. Tan squared x equal 1/3. Now, before you take off with that, let's take the square root of both sides. So the tangent of x has to equal plus or minus 1 square root of 1 over square root of 3, which is 1 plus or minus 1 over root 3. Okay, so again, let's think this through. Tangent is sine over cosine, right? Now, obviously the quadrangles aren't going to even be considered, and neither are pi over 4, because 1s and 0s and square root of 2 over 2 and square root of 2 over 2. So let's just start at pi over 6. And at pi over 6, I have 1/2 divided by square root of 3 over 2. And there we have our winner. Well, it's positive or negative. So if it's pi over 6, it's also going to be 5 pi 6, 7 pi 6, and 11 pi 6. And all 4 of those make this true. All right, let me give you answers and let you write these problems down. 2 cosine squared minus 7 cosine minus 4. Factors of 8 that subtract to give you 7. 8 and 1. And you're going to find your answers are at 2 pi 3 and 4 pi 3. Again, when you're working these out on your own and you have a question, if you don't come up with this answer, just text me on Remind. Yuck, look at 10. Root 3 secant cosecant minus 2 cosecant. All right, get all your like terms together, right? We've got cosecants on both sides. Factor out your common term. And once you're done, you're going to end up with pi over 6 and 11 pi 6. Cosecant is 1 over sine. All right. Now you have cosecant squared plus 4 cosecant plus 4 is 0. Factors of 4 that add to give you 4, 2 and 2. And your answer choices here are going to be 7 pi 6 and 11 pi 6. All right, let's look at 13. The point 2, or excuse me, negative 2, negative 6 is on the terminal side of angle theta in standard position. Find the value of cosine. So this takes us back outside the unit circle. All right, so we're going to draw the point. Negative 2, negative 6. And then I have to find cosine. So we're going back to the basics. A squared plus b squared is c squared. So we have negative 2 squared, negative 6 squared is c squared. Okay. You'll notice I said c equals plus or minus square root of 40, but can that be true? Well, clearly it can't, because if you remember, r is a distance. It is always going to be positive. So in this case, c will only be square root of 40. Or if you want 2 square roots of 10. It's really up to you. Now, that's not what they're asking us for, though. They're asking us for the cosine. So cosine theta, of course, x over r is going to be negative 2 over 2 root 10, or negative 1 over root 10. Okay? And let's jump down. Let me give you the answer to 14. Sorry. Sine is 1/5. You're between pi over 2 and 3 pi 2. You know, actually, let me run through this one with you real quick. They're giving me a sine value of 1 over 5, and I know I'm between pi over 2 and 3 pi 2. Well, how do I determine which quadrant I'm in? Well, remember, sine is y over r, and r is always positive. So if my sine value is positive, that means the y has to be positive. So I know I'm in quadrant 2. I have to be. So now I've got a sine value of 1, an r value of 5, and I'm looking for tangent, which means, of course, I have to find cosine. So So now x is plus or minus square root of 24. I'm in quadrant 2. X has to be negative. So x is negative root 24. Or 2 root 6. It doesn't matter to me how you write that out. So my tangent value is going to be 1 over negative root 24. Okay, verify the identity. You may work on only one side. Yikes. Now, initially, I would be thinking of granddaddy identity. So let's just remind ourselves. A squared plus b squared is c squared, and of course it's 1. If I divide by cosine, and if I divide by sine, okay, so does that really even help me at all? In other words, the only thing I can change here is the 1 plus tangent is secant. And that's just going to add yet another term into all of this. There is no 1 minus tan squared. So I think what I'm going to do instead, and again, you're going to take a path and it may work out and it may not. That's why these problems are frustrating. I'm going to change the left side into 2 rational equations. So I have 1 minus tan squared plus over 1 plus tan squared plus 1 over 1. And now here we go, right to left, left to right, denominator, denominator. And now I've got 1 minus tan squared theta plus, there's right to left right, 1 plus tan squared theta. Denominator, denominator, 1 plus tan squared theta. Okay, what does that do for us? Well, clearly we can cross out the tan squares in the numerator. So now I've got 2 over 1 plus tan squared theta. Well, I'm looking for 2 cosine squared theta. So what I know now, this is secant squared theta, and secant is 1 over cosine. So you end up with, let me just run through the mechanics of this. Right? We're going to flip and multiply. So I've got 2 over 1 times cosine squared over 1, giving me the answer I was looking for. Again, don't let those frustrate you. You take off in one direction, it may or may not be the right direction. So don't let it bother you if it's not. I am not going to stop here. You are certainly welcome to do those assignments, but I'm going to move on to notes 5-2. I still have about 10 minutes, so let's use that. Nothing's really changing here. Now we're using identities to solve the equations, but we still have to factor, and that's an important part of this concept. So here we go. Problem number 1. 3 cosine plus 3 equals 2 sine squared x. All right. So we're solving an equation, so let's move the sine squared x to the other side. So I have negative 2 sine squared x plus 3 cosine x plus 3 equals 0. I'm just putting them in descending order. Yeah, okay, well, close, but not quite. So let's think what we know. And again, let's go back to Granddaddy. We just used him in the last problem. So we have cosine squared plus sine squared is 1. 1 plus tan squared is secant squared. And cotangent squared plus 1 is cosecant squared. So what can we do to make our life a little easier here? Well, I've got a sine squared here, and I can write sine squared as 1 minus cosine squared. Is that going to help me? Well, yes, that's going to help you, because now you're going to have all the same terms in the equation. So I'm going to replace this sine squared, so I've got negative 2 times 1 minus cosine squared x. There's the substitution. Keep writing the problem. Plus 3 cosine x plus 3 is 0. All right? Now I've got all the same terms in my equation. Now I can work with that. So let's distribute the negative 2. So I've got negative 2 plus 2 cosine squared plus 3 cosine plus 3 is 0. And put our like terms together. I've got 2 cosine squared plus 3 cosine plus 1 is 0. 2x squared plus 3x plus 1. This isn't anything new. Factors of 2 that add to give us 3. Yes, we've got that. Plus 2 plus 1. So I end up with a factor of cosine x plus 1 and 2 cosine x plus 1 equals 0. And those are my two factors. Take the first factor. I'm going to bleed down the page just a little bit. So I'm saying, okay, I'm looking for where cosine equal negative 1. Well, that only happens in one location, and of course that is at pi. And now I'm looking for where cosine equals negative 1/2. Cosine's negative in quadrant 2 and quadrant 3. So I've got 2 pi 3 and 4 pi 3. All right, let's jump up to problem 2. Cotangent is root 2 cosine x. Yuck. Well, first get all your like terms together, and I can change cotangent. I can make cotangent cosine over sine. So now I've got more cosine in the problem. So I'm going to do that. So I've got cosine over sine minus root 2 cosine over 1 equals 0. Now we've got two rational. So right to left, left to right, denominator, denominator. Here we go. So I've got cosine x minus root 2 times cosine times sine over sine x is 0. Okay. The nice thing about this, the entire equation equals 0. So what happens to the denominator on the left-hand side? Of course, it disappears. So, and I'm kind of out of room here. Let me run this. We can bring this down here, and we have plenty of room. So now I've got cosine x minus root 2 cosine sine equals 0. Remember, I'm multiplying both sides by sine. That denominator goes away. Now this is starting to become manageable because now I see a common factor. First rule of factoring. So I've got my two factors exposed. Where does cosine x equal 0? Well, again, pi over 2 and 3 pi 2. And the sine of some angle equals 1 over root 2. Now, before you short circuit, let's rationalize this. 1 times root 2 is root 2, and root 2 times root 2 is root 4, which is 2. So remember, it seems like forever ago, but when I was saying you don't always have to rationalize, but sometimes you need to, this is a perfect example. Are there any angles of sine that have a value of square root of 2 over 2? And of course there are. And you have pi over 4 and 3 pi 4, yeah. Because it's positive, it's going to be in the top half of the circle. So again, if you don't change that identity of cotangent, you're kind of stuck. All right, 3, there's really no change in identities here. Sine minus cosine is 0. There's no common factor to take out. So I'm going to just set sine x equal to cosine x. Where does that happen? Well, in quadrant 1, cosine is square root of 2 over 2. Sine is square root of 2 over 2, so at pi over 4. In quadrant 2, cosine is negative, sine is positive. In quadrant 3, they're both negative. And in quadrant 4, one's positive, one's negative. And that is not going to work. Let's see how much time I have. Okay, we still have a little bit of time. Let me take your attention over to assignment 5-2. Let me give you answers. I'm trying to figure out which ones I want to work, and let's work problem 1. I've got that tangent in there, and I know I can introduce cosine and sine if I change its identity, so I'm going to do that. So I've got root 3 sine x over cosine x minus 2 sine x over 1 equals 0. So I did quite a bit in that first step. I moved the sine to the left, and I changed the identity of tangent. And now right to left, left to right. So now we've got root 3 sine x minus 2 sine cosine over cosine is 0. Right to left, left to right, denominator, denominator. Of course, the denominator in this, the beauty of this is that the denominator goes away, and I notice in my numerator I've got a common term of sine. So I'm going to factor that out. So now, where does sine equal 0? Well, that happens at 0, pi, and 2 pi. And where does the cosine of x equal square root of 3 over 2? And that happens, of course, at pi over 6 and 11 pi 6. Okay? All right, we've only got a couple minutes left, so let me just give you some answers. Problem number 2, your answer is going to be pi over 2 and 3 pi 2. Problem number, how many problems are on this? Oh, okay, there's quite a bit. Problem number 3, you've only got one answer here, and that answer is going to be pi. You're going to be replacing the sine squared x. So let's look at 4. Let's work this together. First of all, I'm going to multiply both sides by 1 minus sine. And I'm going to change cotangent. So I have cosine x times cosine x over sine x equals 3 minus 3 sine x. So now I've got cosine squared x over sine x plus 3 sine x minus 3 equals 0. Okay, I'm going to let you run with that for just a little bit. And when you finally get to the bottom, you're going to have, I'm trying to see what I've got here, pi over 2, pi over 6, and 5 pi 6. That one's going to take a little bit of manipulation on your part, so don't give up on that. Okay, in the few seconds I have left, I tell you what, I'll just send out the key to this because there are quite a few problems here, a little more than I had bargained for. And again, if you have questions, just text me on Remind. And that is it. Y'all have a good day.